Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will go everything you need to know about geometry for our upcoming test. So this section on deductive geometry is all about finding angles and classifying shapes. So I'm going to start with angles. So we're going to find the value of angles without measuring them. So you need to know each of these types of angles: complementary angles, supplementary, vertically opposite, and angles at a point. So complementary angles make up a right angle, they add to 90 degrees. So if you've got something like this, these two angles add to 90 degrees. So if one of them's 20, x is just going to be 90 minus 20, which is 70 degrees. Now, when you're writing your answer, you need to give a reason. So I'm just going to abbreviate it, writing comp for complementary. So let's look at this one here. These three angles here are supplementary. They make up a straight line, and straight lines are always 180 degrees. So this symbol here means we have a right angle. So what we have is x plus x. These three angles add up to 180 degrees. So x plus x is 2x. So 2x plus 90 equals 180. Now, you know how to solve this equation. We've done a million of those. You subtract 90 from both sides and divide each side by 2. I get x is 45 degrees. Once again, you need to write a reason. I'm just going to write sup for short, for supplementary. All right, vertically opposite angles are equal. That means these two angles are equal, these two angles are equal. Vertical means sort of standing up, opposite means facing each other. So in this diagram here, this angle here and this angle here must be equal. They're vertically opposite. So x plus 30, which is the bottom angle, must equal the top angle, which is 95. Simply subtract 30, you get x equals 65 degrees. Once again, you must give a reason. I'm going to abbreviate vertically opposite as VO. All right, angles at a point add to 360. That's because there's 360 degrees in a full circle. So here, these three angles must add to 360. So note that 170 plus 90 is 260. So when you take x and you add it to 260, you have to get 360, which is a full circle. So that, of course, means, what do you add to 260 to get 360? X equals 100 degrees. You need to give a reason. I'm just going to abbreviate it as AAP, angles at a point. So see, in each of these, we've found the size of angles without actually measuring them. Now we're going to look at doing the same thing involving parallel lines. So for angles in parallel lines, we need to know what's meant by parallel. Two lines are parallel if they will never meet, even if they went on forever. These arrows indicate to you that the two lines are parallel. The three types of angles you need to know are alternate, corresponding, and co-interior. Alternate and corresponding angles are always equal to each other. These two angles must be equal, these two must be equal. That means, like, if this was 100, this must be 100 as well. But on the other hand, co-interior angles are not necessarily equal. They're supplementary, meaning they add to 180 degrees. So alternate angles make a Z shape. It might be a normal Z or a back to front Z. These two angles here are also alternate and therefore equal. Corresponding angles make an F shape, but it can be a weird upside down or back to front F. Turns out this angle and this angle are also corresponding and therefore equal. Co-interior angles are enclosed by a C. Once again, it can be a back to front C. So this angle here and this angle here, they are co-interior, therefore add to 180. So we need to know these so we can find unknown angles. So the kind of question you'll get is like this, where you have to find x. So you have to identify whether the angles are alternate, corresponding, whatever. So note here we have an upside down F. This angle and this angle are corresponding and therefore equal. So x must be 60 degrees. Once again, if you're finding an angle, you need to give a reason why. So I'm just going to write corresp for corresponding. All right, let's look here. We again have a pair of parallel lines. So what would be the value of x? Well, we need to ask ourselves, do we have any alternate, corresponding, or co-interior? Well, here we have a back to front C. This angle and this angle are co-interior, that doesn't mean they're equal, it means they add to 180. So x is just going to be 180, subtract 125. You can use your calculator if you need, you get 55 degrees. I need to give a reason, so I'm going to abbreviate at co-interior angles. All right, this one here is a bit harder. Once again, we have parallel lines, but note x here isn't corresponding, alternate, or co-interior to these angles. But what we can do here is we can draw a line that goes through that's also parallel. See, that means this angle here will be 30 degrees and this angle here must be 50. Why is that? These two angles here are alternate. They form a Z shape and so they must be equal. Similarly, this angle here and this angle here are alternate. They form a Z shape. So X is going to be 30 plus 50, which is 80 degrees, and the reason, alternate angles. All right, let's now look at using this to determine whether or not lines are parallel. See, what I said on the previous slides only works if the lines are parallel. Alternate angles are only equal, corresponding angles are only equal, and co-interior angles are only supplementary if the lines are parallel. So we can use that to do a question like this. We're going to determine whether or not these two lines are parallel. Now, you can't just look at them and say, oh yeah, they look parallel. We've got to have reasons. So note this angle here will be 115 degrees. Why is that? Because those two are vertically opposite. Doesn't matter whether or not these lines are parallel, vertically opposite angles are always equal. Now this angle here is going to be 105 degrees. How did I get that? Well, note that these two angles are supplementary. They form a straight line. They must add to 180. So if this is 75, this is 180 minus 75. So now what we have here, we have two angles that are co-interior, but they clearly don't add to 180. So because the co-interior angles are not equal, we say no, the lines are not parallel. Once again, you must give a reason. So my reason is that the co-interior angles are not supplementary. If you have a pair of co-interior angles that don't add to 180 or a pair of alternate or corresponding angles that are not equal, these two lines cannot be parallel. All right, let's now move on to shapes. So now we're going to look at the angles inside a triangle. So if you have any triangle, doesn't matter if it's a weird triangle like this, you can always draw a line parallel to the base. Now note these two angles here are equal because they're alternate. Note that these two angles here are equal because they're alternate. Now, because A, B, and C are supplementary, A plus B plus C is equal to 180 degrees because they make up a straight line. So A plus B plus C is 180. This proves that the angles inside a triangle, of which there are always three, they always add to 180. We can now use that to find unknown angles. So let's look at this triangle here. So 65 plus 75 is 140 degrees. So what would x be? X would just be 180 minus 140. In this triangle, x has to be 40 degrees because of the angle sum of triangle that I've abbreviated like this. X has to be 40 because the three angles inside a triangle, the three interior angles, they must add to 180. So what about this here? Well, this is actually an isosceles triangle, as we will see. But if a triangle has two equal sides, it also has two equal angles. The equal angles are where the equal sides meet the non-equal sides. These are called the base angles. These two angles have to be equal because these sides are equal. So these two angles need to add to 148. So the reason they add to 148 is because 148 plus 32 is 180. The angles inside any triangle must add to 180. So I can call this one x, x plus x is 2x. So each of these angles is going to be half of 148. It is going to be 74 degrees. Reason, angle, sum of triangle. 74 plus 74 plus 32 is 180. If a triangle has two equal sides, it has two equal angles. Let's now look at classifying triangles. So when we classify triangles, we're naming them. We give them both a side name and an angle name. The side name is determined by how many equal sides it has. So triangles can have 0, 2, or 3 equal sides. 0 equal sides, we call it scalene. 2 equal sides, as we saw in the previous slide, we call it isosceles. And if all sides are equal, we call it equilateral. Note in any triangle, the number of equal sides and the number of equal angles are the same. So if a triangle has no equal sides, it has no equal angles. 2 equal sides means 2 equal angles. And if all of its sides are equal, all of its angles are equal. Now, because the angles in any triangle add to 180, if all angles are equal, they must be 60 degrees. So an equilateral triangle always has 3 angles that are 60 degrees. So the way we name a triangle according to its angle properties is based on its largest angle. So if the largest angle is less than 90 degrees, i.e. an acute angle, then we call the triangle acute angled. Triangles can also be right angled or obtuse angled. Here we call it obtuse because this angle here is above 90 degrees and is therefore obtuse. All right, let's look at a question on this. A triangle has one angle equal to 90 degrees, another equal to 45 degrees. What type of triangle is it? Well, if we have one angle 90 and one 45, the third angle here must be 45. It's 180 minus 90 minus 45. It must also be 45 because the angles inside a triangle always add to 180. So here, because we have 2 equal angles, it means we're going to have 2 equal sides. This triangle has to be isosceles because it has 2 equal angles and 2 equal sides. Its largest angle is a right angle, so we call it a right-angled isosceles. So when you're asked to name or classify a triangle, make sure you give both the angle name and the side name. All right, let's now turn our attention to quadrilaterals. So a quadrilateral is just a 4-sided shape. Now, even if it's a weird looking quadrilateral like this, you can divide any quadrilateral into 2 triangles. This angle, and this angle must add to 180. The angles inside any triangle add to 180. Similarly, these 3 angles in green add to 180. So all the angles of the quadrilateral add to 180 plus 180 add to 360. So the angle sum of any triangle is 180, the angle sum of any quadrilateral is 360. Once again, we can use that to find unknown angles. So these 4 angles need to add to 360. So x is just going to be 360 minus 70, and it has 2 right angles. Remember, they're 90 degrees each. So you can put that straight on your calculator. You get 110 degrees. The reason, you can just put angle sum of quadrilateral. So over here we have a shape. It is a quadrilateral because it has 4 sides. These 2 angles are equal. When you see angles marked with the same thing, like an arc here, they're both red arcs, they must be equal. So what would they be equal to? Well, note that 80 plus 50 is 130. So this angle here, x, and this angle here, they must add to 230. 360 minus 130. These have to be 230 because 230 plus 50 plus 80 is 360, and the angles in a quadrilateral are always 360. So if 2x equals 230, just divide each side by 2, you get x is 115 degrees, and the reason, angle sum of a quadrilateral. So 115 plus 115 plus 50 plus 80 gives us 360. All right, let's now look at polygons. So a polygon just means a shape with many sides. As we've seen, a shape with 4 sides is called a quadrilateral. If it has 5 sides, it's called a pentagon. 6 sides, it's called a hexagon. For 7 sides, it can be called a septagon or a heptagon, and so on. So we can find angles inside these polygons as well. Now note, if we say a shape is regular, it means each of its sides is equal and each of its angles equal. So this shape here is a regular hexagon. It's a hexagon because it has 6 sides. It's regular because each of its sides are equal and each of its angles are equal. So what would be the value of x? Well, we're going to use a similar trick to what we did with quadrilaterals. We're going to divide this into triangles. So we can divide it into triangles like this. 1, 2, 3, 4 triangles. So the angle sum of a hexagon is 1, 2, 3, 4 lots of 180. The angles inside any hexagon always add to 720 degrees. Now, because this shape's regular, each of these angles in red must be equal. There are 6 of them. Just like a quadrilateral has 4 sides, it has 4 angles. A hexagon has 6 sides, so it has 6 angles. So x, each of its internal angles will be 720 divided by 6, which equals 120, and we're done. All right, let's now go back to quadrilaterals and look at classifying them. So this diagram here is complicated because there are many different types of quadrilaterals. So how do you classify or determine which type of quadrilateral you have? Well, I think the easiest way is to ask how many pairs of parallel sides it has. Firstly, if a quadrilateral has 1 pair of parallel sides, it's a trapezium. If it has no pairs of parallel sides, it's either an irregular quadrilateral or a kite. A kite has 2 pairs of adjacent equal sides. On the other hand, if a quadrilateral has 2 pairs of parallel sides, it's a parallelogram. A parallelogram looks like this. It's kind of like a rectangle on a slant. So 2 pairs of parallel sides is a parallelogram. But there are 3 special types of parallelograms you need to know. A rhombus is a parallelogram with all sides equal, and a rectangle is a parallelogram with all angles equal. Now, because the angles in any quadrilateral add to 360, if a quadrilateral has 4 equal angles, each of its angles must be 90 degrees. Now note, a square is actually a type of rhombus and a type of rectangle. A square needs to have both all sides equal and all angles equal. Make sure you know that because people get caught out. People think if a 4-sided shape has all sides equal, it has to be a square. No. 4 sides equal makes it a rhombus. It needs also to have 4 angles equal to be a square. Now, I've drawn the line here because a rhombus is actually a type of kite as well. So this means a square is actually a type of rhombus, it's a type of rectangle, it's a type of kite, and it's a type of parallelogram. I know that's a bit confusing, but make sure you know this diagram, and let's now look at an example where we apply this. So a quadrilateral has 2 angles equal to 130 degrees and 2 angles equal to 50 degrees. All right, let's draw 2 random quadrilaterals here and fill in the angles. So let's say this angle is 130 degrees. Well, there's 2 options. Either the 130 degrees can be opposite, not touching the other 130 degree angle, or the 130 degree angles can be next to each other. So what would be these 2 shapes? Well, if we look at this shape here, note here that these 2 angles are co-interior and they add to 180. That means that these lines must be parallel from what we learned before. But similarly, these 2 angles here are co-interior, they make a C shape, and they add to 180. So these 2 lines, must be parallel. So one option is that the shape is a parallelogram. What about the other shape? What must it be? Well, here you've got 130 and 50. These 2 angles here are co-interior and they add to 180. So these lines would have to be parallel. On the other hand, these two lines are not parallel because 130 and 130, these two are co-interior, but they don't add to 180. They're not supplementary. So either the shape has two pairs of parallel lines, making it a parallelogram, or it has just one pair of parallel lines, so it's a trapezium. So note, it definitely can't be a rectangle or a square because rectangles and squares have all their angles equal to 90 degrees. So these are the two possibilities. All right, one more thing to look through, concave versus convex. So convex shapes have these three properties: no reflex angles, diagonals are inside the shape, the vertices point outwards, and it's basically the opposite for concave. Now, all of the special types of shape I went through are convex. A square is convex. So it has no reflex angles. You know a square has all its angles equal to 90 degrees, and reflex angles are more than 180. So the first one's checked for a square. The diagonals are inside the shape. Diagonals are lines that join vertices that are not next to each other. Every quadrilateral has two diagonals that are these blue lines here. Both the diagonals are inside the shape. We have satisfied the second. And note here, all of the four vertices, they're pointing outwards. They're pointing this way, away from the center of the shape. That's what convex means. So it turns out all squares, parallelograms, rectangles, rhombuses, kites, trapeziums are always convex. For a concave shape, you know it because it's caved in. Concave shapes look like this. This is a quadrilateral because it has four sides, but it has a reflex angle. This angle here would be more than 180 degrees, so it's got a reflex angle. Now, it has a diagonal outside the shape. As I said before, a diagonal is a line that joins non-adjacent vertices. So this line here is one of the diagonals, this is the other. Note, one of the diagonals is in, one is outside the shape. Concave shapes always have a vertex that points inwards, and that's this one here. It's pointing towards the center of the shape, whereas all the other ones are pointing outwards. So concave shapes, you can see them because they're kind of caved in and they have these three properties, whereas convex shapes, which is most of the special quadrilaterals that we know, they have no reflex angles, diagonals inside the shape, both of them, and all their vertices point outwards. All right, sorry for the long video, but thank you so much for tuning in. Best of luck studying, but you'll ace it. You're a star. This has been the luckiest maths teacher in the world. Have a great day.